Hi, today we want to talk about reproducible research. Why do you want to do reproducible research and how do you do it? Well, one of the reasons you want to do reproducible research is it makes your conclusions carry more weight. If others can reproduce your results, then they know that they are valid. Also, others can build off of your work to add future content to it. But probably most useful is doing it for your future self. If you're anything like me, you're going to come back and look at this material in the future. Like 3 months from now, you come back and look at the work you did and you don't remember exactly what you did or why you did it. So we want to make our results completely reproducible so that we can do them again later if we need to, and then change them. So how do we do this? Well, you start by documenting everything. You start with the question and the raw data. So what we'd like to do in reproducible research is read the raw data in from the data file and then do all of our analysis where we can capture it. Now think about when you use like an Excel spreadsheet or something like that, where you manipulate the data and you touch the fields and do things to them before you actually import them to start your analysis on them. Then you either have to document each of those keystrokes and remember what you did, or nobody can reproduce those results. So we want to bring in the raw data into our analysis document and do any cleaning up and any manipulation there. Another thing we want to do is have all of our files as text files. So our documentation files are text files, and our data files should be CSV files where possible. This gives us platform independence and future-proofs our code. If you think about how fast different applications come about and how we change from one application to the other, right? If someone has a Google Doc versus a Word document versus some other document format, right? You need to be sure that whoever's using your code can read that document in. And you want to be sure you can read that document in 3 years from now when the applications have changed. So to make your code readable, you want to include lots of comments, especially saying why you did something. Sometimes it's helpful to say what you're doing, but if your code is good code, it should be readable in that extent, but it won't tell you why you're doing this. Also, pay attention to formatting in your code, things like indentation. Putting spaces around things like your equal marks or your arrows, things like that. Give meaningful names to both your files and your variables. And then each code chunk or script should accomplish one small task. Don't have something that's hundreds and hundreds of lines of code in one function, if you will. And last but not least, you should use relative paths and not absolute paths when referring to files on your computer, because those who come after you or yourself in the future will not have the same folder structure that you have. So you want to make sure that you are doing things like referring to, say, the data folder within this current directory, or a file that's one unit up, one level up in your directory. Now, we are going to be doing our reproducibility using R Markdown when we're using R, or Jupyter Notebooks when we're using Python, so that our work is reproducible. I have given you the link here to the R Markdown reference guide. It's a cheat sheet that you can use. You can get to the reference guide from the help on RStudio. There's also a new book on R Markdown that you can reference. And I have linked here a YouTube video by Garrett Grolemund that will explain get you more in depth on the importance of using R Markdown. Now, in the next video, we are actually going to walk through creating our first R Markdown document and create one of your own.